Greetings, Sky Watchers, and welcome to a new season, Milky Way Core season. June started with a less than impressive solar storm. Scientists are exploring ways to refuel active satellites, extending their lives and reducing the amount of trash in orbit. And at the tail end of last month, the Juno spacecraft discovered a large lake of lava on Jupiter, furthering the theory that it may have been the first planet to have formed. It's June 2025, I'm Science Ben, let's transport outside and discover this month's sky. We've transported to this morning's pre-dawn sky for an attempted glimpse at some shooting stars. Radiating out of the Water Bearer constellation, the Arid meteor shower peaked this morning around 10 a.m. Not to worry, it will continue until the 24th. Averaging up to 16 meteors an hour for us here in Danville, this is an early morning shower, making peak viewing times just before dawn and when the radiant is high in the sky. Continuing to tonight's sky, we discover a bright moon east of the T with a tail that constitutes the summer constellation Scorpius the Scorpion. Tomorrow night's moon will be even brighter when it reaches full illumination for the month. A full moon in June is sometimes called a strawberry moon. Not because it appears to change color, like during a blood moon, but because it often corresponds with the peak of strawberry season. We won't see a red moon this month, but we will be able to spot a red planet. Mars traverses through Leo the Lion this month. On the 16th, it will appear especially close to Alpha Leonis, the star Regulus, giving the false impression that the two lights are a double star. In reality, Mars is about 161 million miles away, while a trip to Regulus is 77 light years. Not close together at all. While Mars will appear close to a star, 2 days later, the mornings of the 18th and the 19th, gas giant Saturn will appear close to Earth's moon. That's right, Earth's moon. Saturn can't have it, Saturn doesn't need it, it already has 274 of its own. While Jupiter is the biggest planet, it only has 95 officially recognized moons. Jupiter has a density more than twice that of Saturn's. Denser objects have more gravity, so Jupiter should have the larger number of moons. But it doesn't. Why? Jupiter is 477 million miles from the Sun. Saturn is 890 million. This position may put Saturn in a location with more material that could be brought into its orbit. Saturn's beautiful rings may also contribute to its lunar collection. Debate goes back and forth as to if the ring material can escape and condense into new, additional moons, or if the material is broken remnants of previous moon collisions. Advances in technology and the use of new techniques like the shift and stack method, where sequential images are stacked on top of one another following the movement or shift of a moon, resulting in the moon appearing brighter, making it easier to find, are helping scientists discover more moons of Saturn. The full number and reason for abundance is still a bit of a mystery. Astronomers hope to discover more via NASA's Dragonfly mission to Saturn's moon Titan, which is expected to launch in 2027. Saturn isn't the only planet that defies expectations. On the 28th, Mercury reaches its apparent furthest distance from the Sun, resulting in it making its longest journey across the evening sky, greatest elongation. Mercury will also be at dichotomy. When viewed through a telescope, the planet will appear half illuminated, similar to a quarter moon. Mercury is the closest planet to the Sun, just 29 million miles separate the two. That should make it the hottest planet, but it's not. Why? Atmosphere. Not only does Mercury have phases like our moon, it also has craters. 414 named ones to date. That's because, like the moon, it has no substantial atmosphere. Rather, it has a thin outer boundary of gases called an exosphere. While the sunlit side of Mercury can reach temperatures of 800 degrees, the nighttime side drops to negative 290. That's because Mercury's atmosphere does a poor job of trapping the sun's heat. Venus has a dense atmosphere, the densest in the solar system. This doesn't just protect the planet from small impacts, though Venus does have craters, but it also traps in carbon dioxide, enhancing the sun's radial heat via a greenhouse effect. Venus can reach temperatures of 870 degrees, making it the hottest planet. Neptune is 2.8 billion miles from the sun. At that distance, it takes light 4 hours to reach the planet. Surely, it is the coldest planet. Uranus is the coldest planet. The surface of Neptune averages negative 353 degrees. Uranus can reach temperatures of negative 371. The Earth doesn't spin like a top, straight up and down on its axis, but rather, it is tilted slightly at 23.5 degrees. Uranus has a tilt of 97 degrees, placing its poles nearly in line with its orbit. Uranus spins on its side. This unique tilt, combined with Uranus's solar distance, results in 42-year periods of light, followed by 42 years of darkness at its poles. One theory as to cause is that the planet experienced a major collision during its formation, resulting in the drastic lean, and, in the process, knocked free some of the planet's primordial heat. The core of Uranus is made of magnetic ice that radiates only as much heat as the planet absorbs from the sun. Earth's core can generate temperatures of 11,000 degrees, competing with the surface of the sun. Our solar system doesn't like to follow the rules, but we do. At least one rule. That of bringing you new astronomical discoveries the second Tuesday of each month, which we will next do the second Tuesday of July, July the 8th. We'll catch up then. Thanks for watching and keep discovering. Bye.